So means as your computer, so you receive a collide frame and you realize that, oh, I receive a collide frame. So what you will do? You will punish yourself and you will go in integral wait state for some second. Let's say for 1 second. Okay. But why? But what is integral wait state? Integral wait state is that wait state in which you are only receive the data. You will not send the data for some second, right? But why I will go in integral wait state? Because why collision occur? Because communicating pairs are more. So in this, if I also go for communicate, if I also go to send the data, then there might be a chance to increase the collision, right?
Yeah.
So that is why, as a computer, as a device, I will go in integral wait state for some second. So it means if all the computers receive the collide frame, so for a second, the whole network is stopped. So
Yeah. So
the
just to
drawback of
clear,
collision.
like
Yes.
one
Hmm.
computer will receive all the packets from other sender as well, isn't it? Like collision packets and all the data, and computer will check the CRC code and check for the collision. Now other packets also detecting as collision packets, isn't it?
Yes, because this is a hub. So what happen in
Yeah.
hub? What happen in hub? Everything goes to each and every computer,
Yeah.
whether it is for you or whether it is not for you.
Yeah.
Okay, everything is go for everything, everyone. Like everyone will receive each and everything, and the computer will decide whether the frame is come for computer or not.
Yeah. So that will be
Because
checked by using CRC, isn't it?
yes, by using CRC code. So as a computer, when you receive the frame, normally or collide frame, you always check the CRC code and you match the CRC code with the data.
Okay.
And if it is match, then you came to know that okay, the integrity is good, the data, the integrity is good, the data is good, and you will receive the data. You will accept the data. But if the CRC code and data is not matched, their parity bits is not matched, then you came to know that okay, I receive a collide frame, right? I receive a collide frame. And when you realize that you receive a collide frame, so you punish yourself, you go in integral wait state for particular 1 second or 2 seconds to avoid the
And try
more
it again.
collision. So yeah,
Okay.
to avoid more collision.
Gosh. Another one thing, like this, does the receiver knows the CRC code?
Mhm. The CRC code is added by the sender PC.
Send a PC.
Yeah, let's say I am sending a file to you. So my
Hmm.
computer will add the CRC code,
Into the packet.
yeah, into the packet,
Okay.
which is called cyclic redundancy check, which is called FCS, frame check sequence. Got it?
Yeah. So I'm a little bit foggy on these data frames. Um, so the CRC check was a parity bit, isn't it?
Yeah,
Basically.
it is a parity bit. It shows
Yeah.
what is there in the data. What is
Yeah.
the sequence of the data?
What is the sequence of this? Yeah.
Yeah,
So
what is
my
yeah.
my question was like, just say computer A sending to computer B,
Hmm.
and how does the computer B knows this packet coming to you?
Yeah, because of the Mac, because of the
This in
Mac.
the Mac. Ah, okay,
Yeah,
okay, 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 yeah, I got it.
this is in the Mac. So from here it came to know that oh, this packet is for me, and
Me.
after realizing that this packet is for me, it will accept the frame. And later on, I'm going to show you each and everything. Don't worry, today only. Today only, I will show you how communication take place in the network hands-on experience. My hands-on experience as a network engineer. Right? Okay. All right. So now let's continue. So this is called your CSMACD, in which two computers can communicate, but only one person can communicate at a time. If two computers communicate at the same time, then their data get collide. And how they detect whether data get collide or not? With the help of CRC code. So
Yeah.
whenever any computer receives a frame, it check the CRC code, all right. And if the CRC code and data is matched, then the frame is okay. And if CRC code and data is not matched, then computer detects that it receives a collide frame. And as soon as computer detects that it receives a collision frame, it receives a collide frame, it goes under integral wait state for some like for some seconds to punish himself or to avoid the collision. All right, not to
Oh,
punish
yeah.
himself, to avoid the collision. All right.
Mm.
So this is what your collision CSMACD. Okay. So this is the CSMACD. Okay. So while watching the video, you can pause the video and you can learn this. Okay. You can read this. All right.
Yeah.
Now the next topic is MAC address. Now what is this MAC address? Okay. So let's say you are in an interview, and as a interviewer, I am asking you, hey Dennis, what is MAC address? Now, how you are going to explain what is MAC address?
It's a unique number assigned to each device
Mm-hmm.
um, for identification purposes.
Mm-hmm. That's it.
Yeah.
See, to having a knowledge is a good thing, and how you express your knowledge in your interview is another thing. Okay, so I'm giving you wordings. So MAC address is of 6 octet, 6 byte, 48-bit hexadecimal address in which 0 to 9 numbers and A to F alphabets are used. All right. Now
Yeah.
I'm going to explain you each and everything, and I'm going to prove each and everything. See, anything which is stored in our computer or mobile is having some size. So MAC address is having six fields: one, two, three, four, five, six. So MAC address is having six field, right?
Mm-hmm.
And the size of one field is of 8 bit. One field size is of 8 bit. So
Yeah.
if the size of one field is 8 bit, if the size of one field is 8 bit, then what will be the size of all bits? It is total of 48 bits. So
Okay.
the total size of the MAC address is of 48 bits. And how come it is possible? The size of one bit is 8 bit, and there are total six field in MAC address. So that is why the total size of MAC address is of 48 bit. So
Okay.
one point is clear to you
Yeah.
now. Now if you join 8 bit, it becomes 1 byte. 8 bit is equal to 1 byte. Okay.
Yeah.
So if one field is of 1 byte, then six field is of 6 byte.
Yeah.
So I prove second point also. Now the group of 8 is called octet. The group of 8 is called octet. Like 8 zebra group is one octet. 8 chairs group is one octet. 8 bottles group is one octet. The group of 8, anything which is in a group of 8 is called octet, right?
Mm-hmm.
So here also the group of 8 is there. 8, 8, 8, 8, 8. Like, so one field is said that one octet. So if one field is of one octet, then six field is of six octet, right?
Mm-hmm.
And plus here everything numbers and everything are same. Like 0 to 9 numbers are using, and A to F alphabets are using. So any place where 0 to 9 numbers and A to F alphabets are used, so that is called an hexadecimal address.
Yeah.
Okay. Now MAC address has multiple names. MAC address is also called as physical address, hardware address, layer 2 address, machine address, burn-in address. So like MAC address is having multiple names. Alright.
Yeah.
So now you know what is MAC address.
Yeah.
So MAC address is of 6 octet, 6 byte, 48-bit hexadecimal address in which 0 to 9 numbers and A to F alphabets are used. MAC address is also called as physical address, hardware address, layer 2 address, and burn-in address. Alright.
Okay.
So now you have a proper definition of MAC address. Okay.
Yeah.
Now, so can I change the slide?
Yeah.
Alright. Now, one more, another will go in more deep. Every computer or every device in this world has a unique MAC address. Okay. No
Yeah.
device in the world is having a same MAC address because it is managed by IEEE. Okay.
Yeah.
All right. Now, what is ping? What is ping? There is some kind of noise is coming from your background, like, yeah,
Is it?
like this. Yes. So next is ping. Next is ping, packet internet gropper. So what is ping, Dennis?
Uh, Normally we used to check the connectivity
Mm-hmm.
and then the latency.
Okay.
Mm,
Have you ever pinged a device?
yeah. Yeah.
Yeah. So basically, ping is a tool. Ping is a tool, or you can say it is an application of IP. Okay. Right now we are working on TCP/IP.
Yeah.
Okay. The TCP/IP is the protocol on which currently we are working. We are talking with TCP with the help of TCP/IP. So
Mm-hmm.
IP is an upper layer protocol stack. What do you mean by upper layer protocol stack? Upper layer protocol stack is a stack in which there is multiple software tools and applications are there. Okay. So IP is a upper layer protocol stack which contains thousands and hundreds and thousands of applications and tools. Okay. So ping is one of a tool of IP which is used to get network layer status of connected device. Let's say, for an example, let's say, see here, if you see this, this is my computer which is having IP of 10.0.0.1, and this is your computer which is having an IP of 10.0.0.2, right? Now let's say I want to share some file with you, or we want to play a game on LAN. So first of all, I have to check the connectivity, right?
Yeah.
Whether our computers are connected with each other or not. So what I will do, I will ask that, hey Dennis, what is the IP address of your computer? So you will give command IP config and you will take the IP address and you will tell me that, hey Sohail, I have an IP address of 10.0.0.2, right?
Yeah.
So what I will do, I will go to my command prompt which is CMD and I will
Mm-hmm.
type ping 10.0.0.2. Okay. So
Yeah.
after giving this command, immediately reply are coming, right? So let me show
Yeah.
you how to ping. See, if I ping my gateway, ping 192.168.0.1, see the reply is coming,
Yeah.
right? So very fast reply are coming, right? So now what's happened when you do the ping to any device or any computer? So what happens is your computer sends the ICMP echo packet. Internet Control Message Protocol echo packet. Okay. See, these are the packets. See, packet send for, receive for, loss 0. Okay.
Yeah.
So whenever we do the ping, so our device sends the ICMP echo packet. Okay. And this ICMP echo packet goes on the with the help of wire. It goes to connected device and check the network layer status of this device and again back to my computer. So anything which is back again, it shows that the connected computers are connected with my computer, right?
Mm.
Second thing is delay. It's showing that delay also. See here the timing. See the millisecond, minimum 2 millisecond, maximum 3 millisecond, right?
Yeah.
See here it is showing that delay. This is called the delay. Delay means the timing in how much time it back to my computer.
Mm.
And last one is drop. Drop shows the link quality. See here, here there is no drop, 0% loss.
Yeah.
0% loss means my link quality is good. There is no drop. My link quality is good. Okay.
Yeah.
So in short, if we say that what is ping? So ping